All right, welcome back. Here we are going to start in on Chapter 5 of Campbell's Biology, Structure and Function of Large Biological Molecules. This by far is one of the most important chapters that we will address. This is something that if you learn this information well, it will serve you greatly as you progress in biology. All right, so we'll start off with concept 5.1. Macromolecules are polymers built from monomers. Okay, again, a lot of words that we're probably not familiar with. Let's start off with macromolecule. So macromolecule is simply a very large molecule and are typically complex. Okay, probably could have guessed this from the word macro meaning large, molecule meaning molecule. Now, these large biological molecules have unique properties that arise from how they are put together and how they are folded, and it essentially comes back to their structure determines their function. Okay, so first of all, what do we mean by large? Okay, so here is alcohol dehydrogenase. It is a protein within our body. Its job is to take alcohol and break it down. So this keeps us from dying when we have a beer. This molecule itself has a subgroup attached to it. This is something called nicotinamide. This group itself contains 71 atoms. And here's the structural formula here. C21, H27, N7, O14, P2. So this subunit, or this little piece that is included in this overall enzyme, is already 71 atoms. So how big must this thing be? Well, we're talking about nearly 6,000 atoms to build this overall structure. So when we mean large, we mean large. Okay. Now, these macromolecules can be broken up into 4 classes. Okay. There are carbohydrates, proteins, nucleic acids, and lipids. Okay. This largely mirrors the information that we see on nutritional labels, right? So it lists the amount of carbohydrates, it lists the amount of proteins, it lists something called the amount of fats. Lipids is just simply another name for fats. We typically don't address the nucleic acid content of food. It's unnecessary for most people, that is. Now, coming back to concept 5.1, we now understand what macromolecules are, but this states that they are polymers built from monomers. So what does this mean? So polymer is simply a long molecule consisting of many similar building blocks. Okay? We see lots of polymers in the world around us. Plastics are polymers that have smaller units that build this larger plastic structure. Glues are oftentimes polymers. So this is not a unique concept to biology. And when we break these polymers into their individual units, we refer to those repeating units as monomers. Okay? Now, of the 4 classes of biological molecules, macromolecules, only 3 of them are polymers. Okay? So carbohydrates, proteins, and nucleic acids are all polymers. You can kind of recognize here that we've already stated that proteins are made up of these individual things called amino acids, that nucleic acids are made up of those nucleotides, A, T, G's, and C's, right? Carbohydrates are built from simple carbohydrates or simple sugars such as glucose, and you can put them together and build much larger things. Okay, so I'm going to play a little animation here of what this type of activity looks like, this building of a polymer. So here we have 2 individual monomers. We're not describing what they are. And what's going to happen is we're going to link these two things together. Well, this doesn't happen by itself. It does require an enzyme to come in. Here we'll call it a polymerase, and we will link these two together. One water molecule comes off in this process, okay? Something to consider is, since we are losing a water or generating a free water in the production of this, we can call this a dehydration reaction, and we'll come back to that in a second here. So here we have three individual subunits linked together through this dehydration reaction, facilitated by an enzyme. You can imagine if we can join them together, we can do the reverse. Here, we add water instead of removing water, and that breaks the linkage, getting us back to these individual monomers, which then we can then recycle and reuse for another construct. Okay. So, synthesis and breakdown of polymers, this is facilitated by enzymes. These are typically proteins, and their job is to essentially bind the individual subunits and put them in a position where the reaction, this dehydration reaction, is likely to occur. Okay? And again, that dehydration reaction takes something such as two OH groups and links them together by the removal of one water molecule, hence the name dehydration. The opposite of that is also true. We can take those polymers and break them down through something called hydrolysis, or hydro, meaning water, lysis, meaning breakage, so water breakage reaction. And it's essentially just the reverse of this dehydration, right? So let's take a look at this. Here we have a short polymer of 1, 2, and 3. We want to add this fourth subunit. Here we have this hydroxyl group, and here we have a hydrogen present. What this hydrogen is attached to can vary depending on what polymer we're talking about, but in the reaction that links them together, we remove the H2O and replace those bonds with each other. So now we have 1, 2, 3, 4, a longer polymer. We remove a water, so it's a dehydration reaction. It's dehydrating this molecule. All right. The reverse is also true. So if we take this 4 subunit polymer, we can add water and break that bond. Okay, this is, again, both of these reactions are facilitated by an enzyme. Okay, they don't tend to happen by themselves. All right, there is thousands of different macromolecules in each of our cells, right? These macromolecules can vary from cell to cell depending on what that cell's job is. They can also vary between species, right? Now, you can build an almost infinite number of polymers from a fairly small set of monomers. We are really, there's no limitation to how many things we can build from these individual subunits. So here we have concept 5.1. Macromolecules are polymers built from monomers. Macromolecules are extraordinarily large. They come in 4 classes: carbohydrates, proteins, nucleic acids, lipids. 3 out of the 4 of these are considered polymers. So a polymer is a long structure of repeating building blocks. Those building blocks are called monomers. So the 3 classes that fall into this are carbohydrates. Their monomers are simple sugars. Proteins, their monomers are amino acids. Nucleic acids, and their monomers are nucleotides, or those A, T's, G's, and C's. We put them together typically through a dehydration reaction where we remove a water molecule, linking the new monomer to a growing chain, and we would call the reverse of that a hydrolysis reaction, which adds a water to break that bond.